In this lecture, we will discuss the insertion of an element in the middle of an array. The content of this lecture is as follows. First, introduction to inserting an element in the middle of an array. Second, graphical representation of the process. Third, algorithm to explain the process of inserting an element in the array. Fourth, C code to implement the insertion of an element in the middle of an array. Fifth, application, a simple project to understand the concept of inserting an element in the middle of an array. Let's start with the introduction and definition of inserting an element in the middle of an array. Insertion in the middle of an array refers to placing an element at a position other than the first and the last positions. In such cases, when the position designated for the new element already contains an element, we must shift all the subsequent elements to the right by one index before insertion. This concept will become clearer during the graphical representation segment. Let's dive into the graphical representation part to get a better understanding of the process of insertion. In figure 1, we observe an integer type array with 5 elements already present and one vacant place. We have an integer number ready for insertion into the array. Our target is to place the new number, which is 16, at index 3. However, there's already an element occupying that position. To prevent data loss, we must shift the element before performing the insertion. As illustrated in figure 1, we notice that the edge is set to index 3, specifically at index 4. There's another number. Hence, before insertion, we must shift both numbers one place to the right. This process can be visualized clearly through the animation provided. Here, the element at index 4 is shifted to index 5 and the element index 3 is shifted to index 4. This creates a vacancy at index 3, allowing us to perform the insertion at that position. This illustrates how insertion in the middle of an array is executed. Now let's look at the algorithm for insertion of element in the middle of an array. Step 1. Initialize a variable I with the total number of elements the array can accommodate. Step 2. Begin a while loop with the condition execute the loop until the value of I is greater than or equal to the target index stored in the variable POS. Step 3. Shift the element in the array one position to the right using the assignment operator. Step 4. Decrement the value of I by 1. Step 5. Once the while loop ends, increase the total number of elements present in the array by 1 as a new element has been added. Step 6. Place the new element at the target position specified by the variable POS. Step 7. Terminate the program at this step. Please refer to the graphical representation to explore the concept of inserting element in the middle of an array. Here is an example implemented in the C programming language for inserting an element in the middle of an array at a position that is already filled by shifting elements to create space for the insertion. We have implemented the algorithm in the C programming language. The C code contains an array of size 4 with 3 elements already present. There are 2 loops. One is a while loop for shifting the elements in order to create space for the insertion to take place, and the other is a for loop to display the content of the array after insertion. The while loop has a condition that it will run as long as the value of the variable I is greater than or equal to POS, the target value. Inside the while loop block, we shift the element to the right and then decrement the value of I by 1. This loop creates space for the element to be inserted. When the while loop is over, we need to increment the number of elements present in the array by the total number of insertions. This will show the updated number of elements present in the array. After this, using direct access to the array using index, we place the new element at the target index. Finally, there is a for loop to display the updated array.